Eye tracking technology for head-mounted displays has been rapidly advancing in recent years, making it possible for researchers to explore new interaction techniques that can utilize our natural eye movements for immersive virtual reality. In this research, we explored the design of natural eye gaze-based interaction. We introduced 3 novel interaction techniques inspired by 3 types of natural eye movements. DuoReticles is an eye gaze selection technique based on the alignment of 2 reticles, an eye gaze reticle and an inertial reticle, and is inspired by eye saccades. The yellow eye-shaped cursor is the eye gaze reticle, indicating the current user eye gaze location. The green cursor is the inertial reticle that follows the eye gaze reticle around. The inertial reticle can only reach the eye gaze reticle when the user gazes at it. The eye gaze reticle is displayed in red when they are aligned. When the alignment time runs down, the selection process is completed. Radial pursuit can be used to make a selection among cluttered objects and takes advantage of smooth pursuit eye movements. When the user gazes at an object, a bounding sphere is created to check the number of objects contained within it. The objects are distributed and expanded around a circular plane in front of the user. During the expansion phase, the user gazes at and pursues the object of interest. If the error is below the threshold level, the object is selected. Nod and roll uses head gesture-based interaction and takes advantage of vestibulo-ocular reflex, or VOR. In this example, the user nods at the painting to enable or disable interaction and tilts her head left or right to cycle through the possible paintings. The head gaze reticle indicates that the targeted object can be interacted with using head gestures. The head gaze reticle also provides visual feedback during head gestures. We conducted an initial study with 3 parts to test our interaction techniques. In part 1 of the study, we compared DuoReticles to a baseline technique of gaze and dwell. We found that the DuoReticles approach was more preferred by participants over gaze and dwell, although there was no performance difference between the 2 techniques. In the second part of the study, we compared radial pursuit to gaze and dwell. We found that radial pursuit was rated higher in terms of satisfaction and lower in terms of fatigue, and found no performance difference between them. In the last part of the study, we let participants interact with nod and roll. They found it was fun to use for short periods of time. From these findings, we recommend designing eye gaze-based interaction around natural eye movements to improve the user experience when interacting in immersive virtual reality.